In this video, I want to go over two more definitions and examples from section 3.3. Let's begin with the remainder theorem. It states if the polynomial f of x is divided by x minus c, then the remainder is f of c. Let's take a look at an example. Given f of x is equal to x cubed minus 4x squared plus 5x plus 3 divided by x minus 2, let's find the remainder. So normally if we wanted to find the remainder, we could do long division or synthetic division. But there's one other trick. If we don't need the quotient and the question only asks for the remainder, then we can go ahead and plug in the 0 of what's being divided. So since we're dividing by x minus 2, its 0 is positive 2, and that's what I'm going to plug in. So plugging in positive 2 into my function, I get 5. And so 5 is the remainder if you had actually done long division or synthetic division. And you can feel free to check that out. Next definition, the factor theorem. And this states if I have f of x be a polynomial, then if f of c is 0, then x minus c is a factor of f of x. And if x minus c is a factor of f of x, then f of c must be 0. Let's take a look at a more difficult example of this. So I'm given a polynomial f of x is equal to 2x cubed minus 3x squared minus 11x plus 6. And we're asked to solve. So we want to find the x-intercepts, or in other words, the zeros of this polynomial. So normally, if I'm given a polynomial, I'm going to set it equal to 0. So I have 0 equals 2x cubed minus 3x squared minus 11x plus 6. If I was solving this and I see 4 terms, I would normally do the cut in half technique and try to factor. Pulling out a GCF out of the left, I get x squared, and I'm left with 2x minus 3. But over here on the right, there's nothing to take out except maybe a negative 1. And I'm left with 11x minus 6. There's no other number in common with 11 and 6. Alright, so as you can see, this leftover on the left and right aren't equal to each other. So that means for this particular problem, doesn't mean necessarily the polynomial is not factorable, but it means this technique of factoring does not work. So let's go back up to the problem. And I wrote something in parentheses. I gave a little hint. Given 3 is a 0. So we can't use normal factoring techniques, but instead I am going to use synthetic division. So I'm given 3 is a 0. So synthetic division is going to help me factor this problem. So 3 is going to go in the corner. Again, my leading coefficients are going to go across the top. So I have 2, negative 3, negative 11, and 6. Quickly doing synthetic division, the 2 drops. 3 times 2 is 6. Add going down, I got 3. 3 times 3 is 9. Adding going down, I get negative 2. 3 times negative 2 is negative 6, and I get 0. Alright, so I knew that going in, my remainder was supposed to be 0 because I gave you that little hint. But what's really important is I wanted these coefficients. So if 3 is a 0, that means x minus 3 is a factor. And these coefficients are the remaining part. So this gives me 2x squared plus 3x minus 2, and that whole polynomial is set equal to 0. Alright, and now I can continue factoring. So x minus 3 is done. Then I can factor this stuff, 2x squared plus 3x minus 2. You can do AC method. For the sake of time, I'll go ahead and give you the answer. This factors to 2x minus 1 times x plus 2. And now to find all the zeros, set each expression equal to 0. And solve for x. So x equals 3, that one we were given in the parabola. Solving for x in the middle, add 1, divide by 2. Oops. So positive 1/2. And subtracting 2, negative 2. And the problem is complete.